Have you ever wished you had a button you could press in an emergency that would instantly blast a loud alarm and alert everyone around you? Hey guys, in this video I'm going to build a panic alarm circuit with the 555 timer and a few components. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 11 jumper wires, 2 1 kilo ohm resistors, 2 10 kilo ohm resistors, 1 0.01 microfarad ceramic capacitor, 1 red LED, 1 BC547 transistor, 2 push-button switches, a 9-volt battery buckle connector, a 9-volt battery, 1 555 timer IC, 1 buzzer, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2, the trigger pin, initiates the timing interval in monostable and astable modes. Pin 3 serves as the output, providing the timer's operational result depending on its mode: monostable, astable, or bistable. Pin 4, the reset pin, is used to reset the 555 timer's internal flip-flop. Pin 5 serves as the control pin, enabling you to adjust the threshold voltage levels used by the internal comparators to set and reset the flip-flop. Pin 6, the threshold pin, monitors the voltage of the capacitor in the circuit. Pin 7, the discharge pin, manages the timing capacitor's charge and discharge cycle. Pin 8, known as VCC, supplies power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1, or ground, to the negative rail. A jumper wire connects pin 8, or VCC, to the positive rail. Bend the ends of a 1 kilo ohm resistor. Insert a 1 kilo ohm resistor into pin 3, or output, and a few rows above the 555. Insert the BC547 transistor into the breadboard so that its base pin shares the same row as the resistor. Insert a jumper wire into the same row as the emitter and the negative rail. Insert a jumper wire from the collector row across the breadboard gap to the corresponding row on the right side. Insert a red LED into the same row as the jumper wire and a few rows below it. The cathode is in the same row as the jumper wire. Bend the ends of a 1 kilo ohm resistor. Insert a 1 kilo ohm resistor into the same row as the LED and the positive rail. Insert a jumper wire into the same row as the cathode of the LED and a few rows below it. Insert a buzzer into the same rows as the jumper wire and pin 8 of the 555. The anode is in pin 8. Insert a 0.01 microfarad ceramic capacitor into pin 5 and the negative rail. Bend the ends of a 10 kilo ohm resistor. Insert a 10 kilo ohm resistor into pin 2, or trigger, and the positive rail. Bend the ends of a 10 kilo ohm resistor. Insert a 10 kilo ohm resistor into pin 4, or reset, and the positive rail. Insert a jumper wire into pin 4, or reset, and a few rows below the 555. Insert a push-button switch into the same row as the jumper wire. Insert a jumper wire into the same row as the bottom terminal of the switch. Insert a jumper wire into pin 2, or trigger, and a few rows below the other jumper wire. Insert a push-button switch into the same row as the jumper wire. Insert a jumper wire into the same row as the bottom terminal of the switch. Use a jumper wire to connect the positive power rails together. Use a jumper wire to connect the negative power rails together. It's time to connect the power supply. Connect the 9-volt battery buckle connector to the 9-volt battery. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. Press the bottom push-button switch to turn on the LED and buzzer. Press the top switch to turn off the LED and buzzer. We have successfully completed the circuit. Let's dive into the circuit and break it down step by step. This circuit is a panic alarm built around the 555 timer IC configured as a bistable latch, meaning the circuit has two stable states, off and on. Once the alarm is triggered, it stays active until it is manually reset. The circuit begins with the 9-volt battery, which provides power to the entire system. The positive rail runs across the top of the circuit and feeds pin 8 of the 555 timer, as well as the buzzer and the indicator LED circuit. The negative terminal of the battery is connected to the ground rail at the bottom of the circuit. Pin 1 is connected directly to this ground rail, completing the power supply for the IC. A small capacitor C1 is connected between pin 5 and ground. This capacitor stabilizes the internal voltage reference of the 555 timer and prevents noise from accidentally triggering the circuit. The 555 timer in this design operates in bistable mode, which essentially turns the chip into an electronic flip-flop. In bistable operation, the output changes state only when it receives a trigger or reset signal. The trigger input, or pin 2, and the reset input, or pin 4, are controlled using two push buttons labeled set and reset. The set push button is responsible for activating the alarm. Pin 2 of the 555 timer is normally held high through R1, a 10 kilo-ohm resistor connected to the positive supply rail. This resistor acts as a pull-up resistor, keeping the trigger pin in a stable high state so that noise does not accidentally activate the alarm. When the set button is pressed, pin 2 is momentarily connected to ground. The trigger pin of a 555 timer activates whenever its voltage drops below 1/3 of the supply voltage. When this happens, the internal flip-flop inside the 555 timer switches state, and the output pin, or pin 3, immediately goes high. Once the output becomes high, it stays in that state even after the set button is released. This is the key behavior of a bistable circuit. The output remains latched until another command changes it. This is exactly what makes the circuit useful for a panic alarm. A brief press of the set button permanently activates the alarm until someone manually resets it. The output signal from pin 3 of the 555 timer is sent through R4, a 1K ohm resistor, to the base of a BC547 NPN transistor. This resistor limits the current flowing into the transistor's base to protect both the transistor and the 555 timer. When the output of the 555 timer goes high, a small current flows through R4 into the base of the transistor. This base current turns the transistor on. The BC547 transistor acts as a switch that controls the buzzer and LED indicator. The transistor's emitter is connected to ground, and the collector is connected to the negative side of the buzzer and LED circuit. When the transistor turns on, it allows current to flow from the power supply through the buzzer and LED and down through the transistor to ground. The LED indicator is connected in series with R3, which limits the current flowing through the LED so it does not burn out. The buzzer is connected in parallel with the LED circuit, so when the transistor switches on, it also receives power. Current flows from the positive supply rail through the buzzer and then through the transistor to ground. This causes the buzzer to sound, producing the audible alarm signal. The reset button is used to turn the alarm off. Pin 4 of the 555 timer is the reset input. This pin is normally held high by R2, a 10 kilo-ohm pull-up resistor connected to the positive supply rail. As long as pin 4 remains high, the 555 timer operates normally. However, when the reset button is pressed, pin 4 is momentarily connected to ground. The reset input overrides all other inputs and immediately forces the internal flip-flop of the 555 timer into its reset state. When this happens, the output pin, or pin 3, goes low. When the output becomes low, the base current to the BC547 transistor stops. Without base current, the transistor switches off. Once the transistor turns off, current can no longer flow through the LED or buzzer. The LED turns off, and the buzzer stops sounding, returning the circuit to its standby state. I hope this video has shown you how to make a panic alarm circuit with the 555 timer. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Just click the link in the description to download your copy now. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.